All right, new day, new class. Let's see, add math. And the first lesson, sorry, the lesson that we did yesterday, I left you with 5 problems, and I'm going to solve those 5 problems for you right now. The first one is this one here. So we're looking at x squared plus 4x plus 1. And to solve this one, we simply have to just find half of this middle term. So plus 4 divided by 2, squaring that, we'll be getting 2 squared. So if I'm getting 2 squared, then this is here x squared plus 4x. Then we say plus of 2 squared minus of 2 squared 2 squared, and then plus 1. So this here is my perfect square, and I'm going to get here x plus 2 squared, and then I'm going to solve this piece on the end here. So 2 2s are 4, negative 4 plus 1 will give me negative 3, and that's my answer. All right, so let's solve number 2. Number 2 is 3x squared minus 6x plus 5. So 3x squared minus 6x plus 5. We factor out the 3, so that's 3 into x squared minus 2x, close bracket, plus 5. And then we take the negative 2 divided by 2, and we're going to square that, and we get negative 1 squared. So we rewrite this as 3 into x squared minus 2x plus of negative 1 squared, and then subtract negative 1 squared, close the bracket off, put back our plus 5. This here is my perfect square form. So I'm going to get here 3 into x minus 1 squared. And then this here works out to be 1. And then negative 1 by 1 is negative 1. And then 3 by negative 1 will give me negative 3. So that's negative 3 plus 5. And I simplify that. 3 into x minus 1 squared. And then plus 2. And that's my answer. All right, number 3 is minus x squared plus 2x plus 4. So minus x squared plus 2x plus 4. So first thing we do is we say minus, open bracket, x squared minus 2x, close the bracket, and then we have the plus 4 out on the end here. So we're going to rewrite the center. So this is x squared and minus 2 over 2 squared, which is minus 1 squared. So that means negative 2x plus negative 1 squared. And then we have minus negative 1 squared. Close that bracket off, put back our plus 4. This here is my perfect square. So I'm going to have negative, open bracket, x minus 1 squared. This here is positive 1. This here would give me negative 1. And negative 1 from out here with that negative 1 is going to give me a positive 1. So I'm going to have positive 1 plus 4, which means I'm going to have negative x minus 1 squared plus 5. Let's go on to number 4. And that is 4x squared plus 8x minus 7. So 4x squared plus 8x minus 7. So factor out the 4, we get x squared plus 2x, close bracket, minus 7. Then we're going to take that 2 divided by 2, and then we're going to square it, so that means we get 1 squared. So that means 4 into x squared plus 2x plus 1 squared minus 1 squared, close the bracket, minus the 7. And then we have 4 into, well, this is my perfect square here, and that would be x plus 1, close bracket, squared, and then we have here 1 squared is 1, negative 1 by positive 1 is negative 1, negative 1 by 4 is going to give me negative 4, and then we have negative 7, and then the answer here is 4 into x plus 1 squared minus 11. That's the last one, number 5, which is minus 5x squared plus 10x minus 3. So minus 5x squared plus 10x minus 3. Let me just double check that. Yeah, that's correct. And we're going to factor out. So I'm going to do this a little bit faster. I'm going to factor out here. So I'm going to get minus 5 into x squared minus 2x, close bracket, minus 3. Then I'm going to add and subtract. So this is negative 2 divided by 2 squared. I'm going to add and subtract negative 1 squared. So I know that right away, minus 5 into that inside of the bracket, when I substitute with this negative 1 squared, is going to give me a perfect square of x minus 1 close bracket squared. And then I'm going to have that negative 1 minusing off. So I'm going to have 1 squared, which is 1, and I'm going to minus off that 1. So minus 1 by the minus 5 is going to give me positive 5, and then minus 3. So I can work this out as minus 5 into x minus 1, close bracket squared, and then plus 2. So this here is basically well, a little less writing. All right. If you mentally do most of the calculations, you don't have to write so much. In fact, it is possible for you to go from writing this to this, skip this, and then reach here. It's possible, but I don't usually recommend it because you make mistakes. This is about the minimum amount of work, and I would recommend so that you don't make mistakes. All right, so that's going to be it for this exercise, and now we're going to go on to today's lesson, which is to complete the square again. But what we're going to be doing is we're going to be using formulas. So let me add a new page here, and let me just put this in text up here with green, and we can say completing the square and we're going to be using formulas. All right, so we're going to be using formulas to complete the square. Now, as I said, we previously learned how to complete the square by manipulating the equation. Now, what we're going to do is we're going to explore an alternative method for completing the square by using a formula. With the formula, you can directly obtain the h and the k value of the vertex form, and just by simply using the a, b, and the c coefficients that you have. So let me show you how this formula would be derived or obtained, and then from there, what we can do is we can just simply solve a few questions so you can get practice with it. Let's first start off by considering, let me just write this here. So we're going to consider the standard form of a quadratic equation. All right, consider the standard form of a quadratic equation, and we're going to be looking at something like ax squared plus bx plus c. And then what I want you to also consider now is the vertex form. So you know what? Let me type this because here. So and the vertex form. Again, we're looking at white here, so let's come on to the next one. And the vertex form that we know already is a into x plus h close bracket squared plus k. All right, now what we want to do is we want to express h and k in terms of a, b, and c. So let's expand the vertex form and compare it to the standard form of a quadratic equation. So we're going to take this, expand it, then compare that expansion to this, and then we're going to see exactly what we get. All right, so that means that if I have a function equal to that is, well, it's of the form a into x plus h squared plus k, and I am expanding that, so expanding x plus h squared, I would get that f of x would be equal to a into x squared plus 2hx plus h squared close bracket plus k. Now I just simply take my a and I distribute it across each of them with the distributive law. So here I'll multiply each of them by a. All right, when I'm finished multiplying each of them by a, I should get something similar to this. So let me see. Using the distributive law, I will be able to get something like f of x is equal to ax squared plus 2ahx plus ah squared plus k. And then what I need to do is I need to now rewrite it in the standard form, right? So I'm going to rewriting in standard quadratic form. So rewriting in the standard quadratic form, I would be able to see that f of x would be equal to, and I'm going to change the colors around here. So I'm going to say a, and then put back my x squared here. And then I'm going to put, let's just use blue in this one. So let's use plus 2ah for my x term. And then at the end of it, I'm going to write it in yellow. This last part plus open bracket here is going to represent ah squared plus k. So this is the constant, right? So I'm going to take this formula and I'm going to see when I compare it to the quadratic formula, which is ax squared plus bx plus c, that, well, you know what, let me just change the color of each of these terms as well. So if I take this and I put it in green, and I take this and I put it in blue, and I take this and I put it in yellow, you can see right away that what I'm going to do, what I'm ending up with, yellow, right? What I'm ending up with is I'm showing that we get, let me just change this here. So we get that a is equal to a, b is equal to 2ah, which would imply that h would be equal to b upon 2a. And then we also get that let me get put c is equal to ah squared plus k, which means that k would be equivalent to c minus ah squared. You know what? Let me just change the color of each of these as well so that you can separate it. So I'm going to put this here in green. I'm going to put this here in blue. And I'm going to put this here in yellow. Right? So you can distinguish what's happening for each of them. So I compared all of the terms. I noticed that this here looks familiar. You know what? Let me just write this here as well. So I'm going to just put here, f of x equal to this. And let me just reselect this and put this yellow. Right? And notice that all I did is I compared the coefficients and I get my formulas for h and k. which is what I really need for my completing of the square steps. So I'm just going to write this down in a general form so that you can get it. Let me just put this here. And the steps for completing the square. And the first thing you want to do is you want to identify your A, your B, and your C. Then the next thing you want to do is you want to calculate each using a formula, and I'm going to write the formula in after I'm finished. Just this one here, 3. The next thing you're going to do, calculate K using, and again, I'm going to use another formula. And then finally, we're going to rewrite. So we're going to write the vertex form by substituting the values for A, H, and K in, well, I'll put the other formula there for you just now. All right, so I'm going to do H, so let me write that in. So H, as we already say, H is equal to 2 upon 2A, sorry, B upon 2A, I'll write that better, B upon 2A, and then K is going to be equal to C minus AH squared. And then we're going to write it in the vertex form, and in the vertex form, again, we just simply need to put in our A into X plus H close bracket squared plus K. And this is rather simple to do, rather simple to understand. All you have to do now is let's do some examples to practice it. Now, what I'm going to do is I'm going to do some of the previous examples. I'm not going to do all, I'm going to do some of it. And what I expect you to do is take the previous examples that we did, or take the previous exercise that we did, and just simply use the formula to calculate it. We already have the answers. If you get the answers correctly, that's done. All right, so I'm just going to do a few examples, only about 3. So let's see, example 1, and we're going to say express f of x equal to x squared plus 6x plus 5 in vertex form. All right, so we're going to express it in vertex form, and we're going to say given f of x, then a is equal to 1, b is equal to 6, c is equal to 5. From there, all I need to do is look up my formulas. So h would be equal to b upon 2a, which is just simply going to be 6 upon 2 into 1, which is 6 over 2, which is 3. And k is going to be equal to c minus ah squared. Let me just write that squared here. And that would be equal to c, which is 5, minus a, which is 1, into h, which is 3, and then square that. And notice the answer for this is going to be equal to, 3 threes, and 9 by 1 is 9, by negative 1 is negative 9. So 5 minus 9 is going to be negative 4. All right, so the answer works out. So hence, the vertex form is, and we're going to call this x plus 3, which is the h, squared, minus 4, which is the k. And that's it. You're done. Okay, let's try another example. So example 2, we are required to complete the square for the equation f of x equal to 2x squared minus 8x plus 3. All right, so we're going to complete the square for the equation that. So given that f of x, then we know that a is equal to 2, b is equal to minus 8, and c is equal to 3. From there, we need to work out the value of h and k. So we're going to say that h, and I'm not going to write back the formula. Well, let me write back the formula. B over 2a, and b is minus 8, and a is 2. So b is minus 8 into 2 into negative 2. And working that out, we'll get here 4. 4 divided by 2 is simply 2. And is it negative 2 or positive 2? Positive 2. So this here is going to be a positive 2. And that means here is going to be a negative 2. All right. Right. So h is that. And then we have k, which is going to be equal to the c minus the ah squared. And then we're going to have c is what? 3? Yeah, 3. So c is 3 minus a is 2. H, which we just calculated, is minus 2 squared. And that would be equal to 3 minus 2 into 4, which is minus 8. So 3 minus 8 is going to be minus 5. And hence, the completed square form is going to be as follows. It's going to be the a value, which is 2. Yeah, a value is just 2. A value which is 2, then x minus 2, which is the h squared, and then the k. And we're done. All right, so that's that. Let's try one last example, and that would be the last one. So let's say example 3. We can say express f of x equal to minus 3x squared plus 12x minus 7 in the form minus 3 into x plus h squared plus k. All right, so given f of x, then a is equal to minus 3, b is equal to 12, and c is equal to minus 7. So that means that h would be equal to b over 2a, and let me just make some more space for here. So b over 2a, that would mean I'm looking at b is what? 12? 12 over 2 into minus 3, so that's minus 6, that gives me minus 2, and k would be equal to c minus ah squared, which is going to be minus 7 minus minus 3, and then minus 2 squared, and working that out we have minus 7 minus, and then 2 squared is 4, 4 3 is 12, minus 12. This here gives me a positive, so that's plus 12, so that means I'm going to get positive 5. All right, and from there, hence, minus 3 into x plus h squared plus k is equivalent to minus 3 into x plus h, which is minus 2, and then squared, and then plus k, which is 5. And I can just put it here again, equivalent to minus 3 into x minus 2, close bracket, squared, plus 5, and that's it. All right, so I can write it whichever way. All right, so that is the end of that one. Right, I'm not going to bother to do any more exercise questions because quite frankly, it's simple. You just put the values into the formula and you get your answer. So try the remaining problems, try the problems that we did at the beginning of this section. So I believe it's this here. So try these exercise problems. You would expect to get the exact same answer here. If you don't get the exact same answer, tell me. If it is that I make an error in the solution, you can just point it out to me. I'll fix it on the video if it's necessary. And after that, that's it. Bye.